Parabolas and Modeling. We can easily change the position of a parabola. Consider the following examples. G of x equals x squared plus 3. If we'd like, we can put this on our calculator. Go to the y equals equation editor. Type in x squared plus 3. When we hit graph, you can see that our standard parabola is not at a vertex of 0, 0 anymore. It's been moved up 3 spaces. So this moved up 3 spaces, or what we call a shift. And let's look at this equation. X squared minus 4, we'll go back into that same equation editor and type over -4. Graphing that, we have the same y equals x squared parabola except pulled down 4. So this has been moved down 4 spaces, or a shift down 4 spaces. Now what happens when we put a -2 inside the parentheses of a parabola? Let's see, we'll have a parenthesis x minus 2 parenthesis squared. And when we graph that, it's taken our standard parabola that was at 0, 0 for the vertex and moved it to the right 2 places. So this has moved right 2 places, and we also can call that a shift right too. And what happens then if we put a +5 inside the parentheses instead of the -2? You can probably guess it's going to shift that left. So when we graph, certainly we can see it's the same parabola, but we moved it to the left 3. So this is moved to the left 5 spaces. Vertical and horizontal translations of parabolas. So if we have h and k positive numbers, if we wanted to graph these equations, and k is of course positive, then we shift that graph by k units upward if we add a positive number to the standard equation, and we shift it downward if we subtract that positive number from our standard parabola. If we wanted to shift our graph left or right, then we need to subtract from the x itself. Notice that that thing that's being added or subtracted is inside parentheses here. So this is moving left or right in an x direction, left or right, because that h has been grouped with the x inside the parentheses. So when we want to shift it right, we subtract some number from the x. If we want to shift it left, we add some number to the x. So here we come upon vertex form. The vertex form of the equation of a parabola with the vertex hk is y equals x minus h quantity squared plus k, where a is not equal 0 and it's a constant. If a is greater than 0, then the parabola opens upward. If it's less than 0, the parabola opens downward. So this a is the same as when we had y equals ax squared. And so now all we're doing is shifting things left, right, up, or down. Let's look at the graph of f of x equals ax minus h quantity squared plus k. So I have here a parabola that's the standard f of x equals x squared, and I'm going to manipulate a, h, and k. We've already manipulated a. If we make it a larger number than a, then it makes the parabola more narrow. And if we make it negative, then it turns it upside down. If we make the number between -1 and 1, not including 1 or -1 or 0, in other words, if a is a fractional type number that's absolute value is less than 1, then we have a parabola that is wider than our standard parabola. So let's say that we keep a at 1 and we want to change our h. Remember that our h is the number that is grouped with the x. So if I make the h a positive 2, then our standard form a times x minus h, which we see is 2, quantity squared, is going to move that parabola to the right 2 places. In other words, if h is a positive 2, it moves the parabola to the right 2. If h is a -3, and then it would move the parabola to the left 3. Let's say we want to put that back to 0 and change our k. We want to change k to maybe a 3. So it's the same parabola but moved up through 3. We can see a times x minus h, quantity squared, plus k. So a positive 3 added on, just tacked on to the end of that function, means that we're going to move the parabola up 3 spaces. So let's remove this, put it back down to the standard parabola. Let's say that we want a parabola that has been shifted to the right 2 spaces. So we make our h2. So the equation is x minus h, which is 2. And let's say we want to shift it down 3. So we would make k a -3. So that gives me a 1 times x minus 2 quantity squared minus 3 equation. And again, if we wanted, we could change the width of that or whether it opens up or down by moving that. So you have there your parabola that has a vertex at hk. In looking at this equation, let's first identify the vertex. Then we'll sketch a graph of the equation and compare it to our standard y equals x squared graph. And we'll state any transformations that are being used. So first, to identify the vertex, it is in vertex form, so we don't need to use our vertex formula. We have an a, which is 1, x minus 3 quantity squared, plus k, which is going to be here a 0. So we have identified the vertex. We have the vertex 3, 0. I like to think of this as thinking of the number you would put in for x that would cause this squared quantity to become 0. That would be a positive 3. And then the number tacked onto the end, and that gives you your vertex. Let's go ahead and sketch a graph of this equation. We have first the vertex is 3, 0, and we can make a t-table here. Remember, we want to put our vertex in the middle and go a couple of points on either side of that vertex so we can capture the symmetry in our table. If I put in a 4, 4 minus 3 is 1, 1 squared is 1. A 5 minus 3 is 2, 2 squared is 4. Putting in a 2, 2 minus 3 is -1, squared is positive 1. A 1 minus 2 is -2, squared is positive 4. So I'm going 1, 4, 2, 1, 3, 0, 4, 1, and 5, 4. So we have a nice set of points that we can draw our sketch through. Make sure you make it nice and smooth, curved. And how does this compare to our standard y equals x squared graph? Since a is 1, it's not any wider or narrower, it's the same. We have shifted it to the right, 3, so we can say shift right 3, and it has not moved up or down. So that's the only transformation that is being used in this function. Now, when we say shift right 3, you want to make sure that you're using the correct language there. Don't say shift over. That's not specific enough. Over could be left or right. So you need to say either right or left when we have a horizontal movement of that function. Let's look at this function. We have a negative x squared, so it's a negative, if we want to rewrite this, it's a negative 1 times x minus 0 quantity squared plus 0. So the vertex, of course, is 0, 0 this time. Let's sketch the graph of the equation. We have 0, 0 in the middle, and we'll go 2 on either side. 1 squared is going to be 1 times negative is a negative 1. 2 squared is 4 times negative is negative 4. A negative 1 squared is 1 times a negative is negative 1. And a negative 2 squared is 4 times negative is negative 4. So I have a 0, 0. I have a negative 1, negative 1, a negative 2, negative 4, 1, negative 1, and 2, negative 4. So we see the nice outline here for us to draw through. And how does that compare to our standard y equals x squared graph? It has not shifted up or down, has not moved left or right. The only thing that has happened is we have turned the parabola upside down, or what we've done is we've reflected it over the x-axis. So like taking the top of this paper and folding it down, it reflected over the x-axis there. Looking at this equation, let's identify the vertex. First we have an a of 1 right here. So the vertex, remember what value of x could you put here to cause this squared quantity to be 0? It would be a negative 1. And the y value is negative 2. So we have the vertex negative 1, negative 2. And let's put our t-table over here. I will put my vertex in the middle and go a couple of points on either side. So a negative 2, negative 3 this way, and a 0 and a 1 that way. Let's go ahead and put in a 0. Plus 1 is 1. Squared is 1. Minus 2 is negative 1. Putting in a 1. Plus 1 is 2. Squared is 4. Minus 2 is 2. Putting in a negative 2. Plus 1 is negative 1. Squared is 1. Minus 2 is negative 1. Putting in a negative 3. Plus 1 is negative 2. Squared is 4. Minus 2 is 2. Let's plot those points. So I have a negative 3, 2, a negative 2, negative 1. My vertex. 0, negative 1, and 1, 2. And we can draw a nice graph here. So how does this compare to our standard y equals x squared graph? Well, what happens here is that we didn't move the graph out or in. We didn't make it wider or narrower, but we did move it to the left one and down two. So we did a shift left 1 and another shift down 2. If you look at the vertex, that explains any of the shifting that's going on. Normally the vertex is 0, 0 for a y equals x squared graph. But here we have a negative 1 in the x spot, which means it was moved in the x direction, negative 1. And we have a negative 2 in the y spot, which means it has moved in the y direction, up or down, negative 2, so down 2. So left 1, down 2. Left 1, down 2. There's your new vertex in your graph. Looking at this graph, first identify the vertex. The vertex is going to be the number that we put in here to make this squared quantity 0. That would be a 1. And the number tacked on to the end, which is a 2. Let's sketch the graph. Let's put a t-table. We'll put the vertex in the middle. And we know that vertex is here. We'll go on either side of that vertex to get some symmetry. Let's go ahead and put in 2. 2 minus 1 is 1. Squared is 1. Plus 2 is 3. Putting in a 3, I get a 3 minus 1 is 2. Squared is 4. Plus 2 is 6. And a 0 minus 1 is negative 1. Squared is positive 1. Plus 2 is 3, as we suspect. And let's hope that this next one is 6. But in a negative 1 minus 1 is negative 2. Squared is positive 4. Plus 2 is 6. So I have a negative 1, 6, and a 0, 3, 1, 2, 2, 3, 3, 6. And we can make our nice sketch of our graph there. And comparing this to y equals x squared, it's the same width, but we have shifted positive 1, so right 1, and positive 2, so up 2. So we did a shift to the right 1, and we did another shift up 2. Let's write the vertex form of the parabola that satisfies the conditions, and then we'll write the equation in this form. First off, let's write the vertex form is f of x equals a times x minus h quantity squared plus k. And then we can fill all of our pieces in. I have an h here and a k here, and my a, of course, is 3. So a is 3 times the quantity x minus h is 3 quantity squared plus k, which is 4. So that's my vertex form. And let's write it in our standard form, y equals ax squared plus bx plus c. In order to do that, all we need to do is simplify this expression on the right side of the equation. So I'm going to first square the binomial that we have there, and then I want to multiply 3 through, so I get f of x equals 3x squared minus 18x plus 27 plus 4, and then I have some like terms I can put together. So f of x equals 3x squared minus 18x plus 31. And as you can see, a is the same as this a, like we've been talking about. The rest of it kind of falls away because of the form expanding and combining. So, but you can still see the a is the same, and you could find out the rest of the parts by using the vertex formula if you needed to. Let's write the vertex form of the parabola shown in the graph, and we'll assume that A is either a positive or a negative 1. And in other words, the parabola has not gotten wider or narrower than the standard y equals ax squared form. So let's go ahead and start with this one. I have a y equals A is 1, so x minus something squared plus something. So x minus, how much did it move left or right? It didn't move left or right any, so that's going to be a 0. And let's get the k. K is how much it moved up or down, and it moved down 3 spaces, so it's going to be a minus 3. So if I want to simplify this, it'd be y equals x squared, no need to put that, and a plus a negative 3 would be minus 3. With this parabola, I notice that first of all it's opening down, so that must mean that my a is negative 1, and my hk is going to be the new vertex of negative 1, 2. So I can put it right into my standard form. Y equals A times x minus h quantity squared plus k. And of course I want to simplify inside that set of parentheses. We can write y equals simply a negative x plus 1 quantity squared plus 2. And just to double check ourselves, we have the negative, it's opening down, and we have the number that we put in here to make this squared quantity become 0 would be a negative 1. So we have a negative 1, and the y is the number tacked onto the end, which is a 2. So that does it for this lesson. Go ahead and try your homework and let me know if you have any questions.